All right, welcome everybody. Hope you guys are having a great show so far at PDC. My name is Gabriel Torok. I'm the CEO of Preemptive Solutions. And
I'm Bill Leach, CTO of Preemptive Solutions.
And today we're going to talk to you a little bit about some of the extensions that we've made to Visual Studio and kind of give you a sense of the code involved in creating them. One of the things I want to start this talk with is our motivations and objectives, why we extended Visual Studio, what were we trying to accomplish, what was the purpose of it. Give you guys a demonstration of that and then do a code walkthrough and take you through and show you exactly how we did it, maybe some pitfalls that we've seen, some real possibilities now that we have 2010 instead of 2008. Many things are a lot simpler. And then give you guys a couple key takeaways and sort of summarize what we've talked about. So first thing, many of you guys here might be familiar with Preemptive as the makers of Dopfuscator. So Dopfuscator, if you don't know, has been shipping inside Visual Studio since 2003. It's off the tools menu, and people primarily think of it as a code protection tool. Well, one thing that's going to be fundamentally different starting in 2010 is Dopfuscator, in addition to doing all the great code protection stuff it does, will now also do code injection for something we call runtime intelligence. And the idea here is that you can take applications that you're going to release in production and monitor and manage them in a very seamless way without writing any code, just checking off some things you want to track. You care about stability, performance, what features are being used. And then all that data will come back up to an endpoint, and it can be surfaced in lots of different places. It can be surfaced on a dashboard. It can be surfaced within, System Center, within CRM, and within Visual Studio. So we can now do something that a lot of people in Agile have been trying to do for a while, which is this idea of feedback-driven development, where you can take information from your applications running in the wild and pull it back into your development process to build better software faster. So, a couple of things here. A little bit of a background on why we did this and how this became to be important to us is, as you guys know, shipping in the box, we've got lots of customers worldwide, and a lot of them, as we began talking to them and thinking about what it is that we do, being an instrumentation platform, is the feedback of, it's really great when you have web-based applications because you can do web trending, but when you've got something that's Silverlight, when you've got something that's running on a desktop, when you've got something that's running on a mobile device, we lose all that information, right? We don't know how people are using it. We don't know the performance. We don't know the stability. Microsoft and large ISVs do, right? So, the top 10 ISVs, you heard in the keynote this morning, they build out things like Squim, Microsoft's internal tool that, is their customer experience improvement program, and things like Dr. Watson, where they can collect information from, how that software is performing in the field and use it to improve their software. But the rest of us don't. So the idea of democratizing Squim is really what runtime intelligence is about. Now, I'm not going to go into the details of how the runtime intelligence is implemented because we just don't have time in this talk. And candidly, this talk is more about extending Visual Studio, and we're going to be showing you code on how we extended Visual Studio. But I don't want to just wave my hands and tell you the rest of this is all magic. If you go look, there's an episode of 10.4. I don't know how many of you are familiar with 10.4. It's a Channel 9 production. And episode 35 actually takes you through using Visual Studio 2010 Beta 2 on how to instrument your stuff so that it does send up all this analytics information. So that piece is not what we're going to talk about, but I want to tell you that it's available and you can go look at it. There's a couple quotes here. We were featured in a couple keynotes last week at Dev Connections and at Tech Ed Berlin. Jason Zander and Dave Medlin were the two Microsoft executives that we were up on stage with, kind of showing all this. And I want to go through with you and just give you a quick overview of the kind of things we went through. So with that, we're going to switch over to the demo here. Okay, so the application I'm going to show you, and the way we're going to do this is I'll go through and I'll show you the application, I'll show you what it is in the Visual Studio extensions, and then after that, I'll turn it over to Bill, and he's going to drill down into the code and kind of take you through the steps of how we did certain things. So the application I'm going to show you is called Witty. Witty is an open source Twitter client, and our first stop is going to be Architect Explorer. Try this. Okay. We're going to go ahead and zoom in on this a little bit here so we can see it a bit better. So Architect Explorer is a tool that basically shows you methods and the graph of their dependencies. Well, we've actually did some stuff on top of that. And the things that is unique to what you're looking at here are there's two bits of information that are important to note. One is the color of the various nodes. The red node is something that wasn't tested very much. Okay, so if you're doing code coverage testing and you haven't done much on something, it'll be red. If you've done a lot of code coverage testing, it'll be green. The little obfuscator icons are indicating that these are methods that we're watching. So the other methods there we're not tracking. So the other thing is the size. So the size here is based on information we obtained from the running applications in the wild of the relative level of usage of these. So if something is large, it means it's being used very frequently in production. If something is small, it's not being used very much at all in production. So something that's large and red indicates a problem because you haven't tested it very well, but yet it's being used a lot. So why don't you go ahead and click on that. And so we're going to zoom in on Ignore User. Now, this takes us over to the code editor. Now, one thing that you might immediately notice is that there's a margin on the code editor, right? That's not there as by default, right? And that margin indicates the positions of the methods that we're tracking with Runtime Intelligence. So these methods have unique information with them coming from the field on performance, stability, and usage. And as you scroll down, you can see that we use WPF transitions to do these rollouts to give you a quick graph of the relative usage of these methods in production. And if we scroll down where there's a red one, that indicates that it failed a Runtime Intelligence threshold test. So what that means is that we've set up a threshold. Maybe it's based on usage. Maybe there's something that's changed a lot recently, so it might be something we want to notice. Maybe it's something that changed a lot and isn't being, there's no code coverage on it. Maybe there's some performance issues. But in any event, it's something we probably want to drill deeper on. So if we go ahead and left-click on it, it'll take us over to where that method is. And then if we right-click on it, what it will do is it will surface a WPF graph right in line with the method. So as you can see, we didn't just put it there because we don't want to sort of cloud your development experience with a bunch of stuff, but it's there available for you to look at should you choose to. And this graph indicates the usage by month of this method. So you can see over time that Ignore User really spiked up in about May. Its usage really spiked up. Now, one of the things that's interesting is that a new version of Witty was released in May, but Ignore User is simply a dispatch method, and it didn't change in May. So the method itself didn't change in May. The application did, and usage spiked. So interesting. So we'll go to the next graph, and we'll see here that we're also tracking the parameters that are passed into this method, and we see that starting in May, we added 2 new parameters, right? So we've essentially created 2 more ways of ignoring users. Now can't imagine why you'd want to ignore somebody in Twitter, but anyway, there's new ways to do it, and apparently they're quite popular. So the usage spiked of this. Well, our code coverage testing is not in alignment with this. In other words, we have not been testing these things. So it probably makes sense for us to circle back and do that. So this is alerting us to that fact. Now, the other thing you can do here is there's multi-dimensional runtime data that simply we can't fit everything inside the editor. So you can actually click on this graph, and it will open up the Runtime Intelligence portal. And inside the Runtime Intelligence portal, you can track a lot more information. So you could scroll down and track, feature ratio usage, number of incomplete sessions based on different methods that were called, feature usage over time. You can trend. All of this data is exposed with a RESTful API, so you can actually take and aggregate this with other systems. So you can pull them into systems that make sense. Maybe you're doing evaluations and you want to aggregate it into CRM. Maybe there's something you want to pull into System Center. But wherever it makes the most sense, you can take this data and you can integrate it with business logic. So we'll go back to Visual Studio here. So the next thing we want to do is lift the curtain. Okay, so how did we do this? How did we build these extensions inside Visual Studio? The first thing I want to point out here is there's three main points to these editor extensions I want to bring up. The first is that the editor is fully WPF enabled. So your extensions can and should leverage WPF. The second is that these extensions interact with Visual Studio and vice versa through MEF. And I'll talk a little bit more about MEF in a bit. And the third is that the extensions have a new Xcopy deployment model, which makes shipping these extensions very simple. And Bill will touch on how that's done. And there's actually a place Microsoft provides for you to actually go look at all the extensions that have been built and people are exposing publicly. So with that, I'm going to turn it over to Bill, who's going to step into the editor and take us through some more stuff.
Thank you. I'm going to switch briefly over to the demo just completed and outline what we're going to talk about here in the next few demos. We have, as you can see, let me drive this thing over here. We have this margin here. Our first demo, we're going to build the margin. And you probably didn't see it before because it's not obvious. But as I move through the view here, I don't know if you can see, there's a little glyph on the side of the margin that tracks where you are in the viewport. We're also going to implement that. So we're going to show how to build a margin and how to track the viewport. The second part of the demo will build what we call a document map, which is, it maps parts of the code in the buffer to the margin. So these glyphs here, the ones that track the runtime intelligence data, are mapping to methods in the source file, and we're going to position those on the glyph to scale. And then we're going to provide navigation so that we can click on them and go easily to the method that we care about. That's the second demo. The third demo, we're going to implement the inline adornments, as they're called in Visual Studio. These pictures in line, which are really live graphs, but they're treated as WPF controls, and you can lay them in and reserve space for them in the editor as adornments. So we're going to do that. And the last part we're going to do is this light box effect. I don't know if it seems pretty clear on the monitor. Sometimes it doesn't show up, but you can see that the method that we're zeroed in on right here with the chart has a light box around it. So the other code in the editor is sort of shaded. So I'll show you how we did that.
Okay.
So a couple notes about the demo. I'm not going to be writing code live. There's a lot of code, and I think you'd rather see the highlights than watch me type and cut and paste and things. So what we're going to do is I'm going to load things up. I have strategically set breakpoints, and then we can go through and talk about specifically the Visual Studio integration points that I use to do this. And the last thing I want to mention is that the code you're going to be seeing, it's stripped down a little bit for simplicity, just in the interest of time, but it is pretty much the code we're using as we're developing the production version of this. So.
Okay. So while you get that set up, I'll just mention briefly here. I mentioned MEF earlier, and I just want to explain what that is a little bit more. I'm sure many of you already know, but MEF is a managed extensibility framework. And it's a framework for composing loosely coupled applications dynamically. Visual Studio uses MEF to implement the editor extensibility, so you need to be familiar with it. It works via custom attributes. That's also one of the ways that you can configure Obfuscator, so we're very familiar with it. Components advertise their services by exporting them. Consumers, in turn, import the services they want. And another important point to note about MEF is that it comes with the .NET Framework 4.0. So you have to have the .NET Framework 4.0 to be using MEF. So I'll turn it back over to Bill.
Okay, I'm not quite ready yet, but
Okay.
I am struggling with the fact that my monitors are not quite right. So I am going to briefly reset the demo because I have a different file here. This is actually a good chance to show you the extension manager, which I call it the control panel for extensions. So I've got some extensions here. You can actually enable and disable them from here. So I'm going to enable the demo extension and disable the one you just saw, and that will get us going with the next demo.
Excellent.
Let me close that. And so here we are. This again is the margin demo, and I'm going to cut over to the slides real quick now that that's set up, and we will talk about some things I just told you. We're going to build the custom margin and the viewport tracking, and Gabe already told you about MEF, so I'm going to lead right in and say that in this particular demo, we're going to use MEF to export the IWPF text view margin provider. What that is an interface that we've implemented. It's a Visual Studio API. And Visual Studio, once it figures out that you've exported it, that sort of advertises it to Visual Studio, and it will, as it starts up, take note of that and call the create margin method in response. That's the method specified by the interface. So our implementation of this provider is a factory that creates our margin. The margin itself implements IWPF text view margin, which specifies a piece of UI real estate in the form of a WPF control. So all of this is WPF under the hood, and our margin actually inherits from the border control. And the last piece is that the margin gets a hold of this thing called a text view. And the text view is another Visual Studio API interface, iTextView. And that's the view part of a model view controller model. So everything in the editor is represented as a view of text with an underlying buffer that represents the model. And both the view and the buffer have events that you can listen to for changes and whatnot. So with that, I'm going to switch back over to the demo and run it.
Excellent.
And hit our magic breakpoints. So here we're launching what's called the experimental hive. If you're familiar with the Visual Studio SDK, you can actually create a separate instance of Visual Studio which protects you from messing up the one you're developing under. So this is the experimental version, and it will load our extension when it's ready. It's thinking about it. There we go. So what I'm going to do now is load our test file from WIDI. I'm just going to load the file. And we should see some breakpoints in a second. Okay. Our first breakpoint is in the create margin method. Again, that is called from Visual Studio because we've exported it. So here's our export attribute. So MEF is configured through custom attributes. So this is where I say I want to export this interface definition for people who are looking to compose. There are some other attributes we use for configuring things. So we have a name for our margin, so we can look it up later. We specify here where in the editor the margin should be laid out. So obviously you can lay out a margin on the right or the left, and also the top and the bottom of the editor. The next thing is a content type, which says we only want to show this margin for views that contain code. And the last is we're specifying the role of the text in the buffer should be a document. A document is something that has a beginning and an end, like a code file. So we're blocked here in our create margin, and we're using that to actually create our margin, and we're passing it our text view. My next breakpoint is in the constructor, and this is where we do all that interesting WPF stuff. So we've stored all of our resources in a XAML file, and we're loading it as a resource dictionary. So that's what this is. And the margin itself, like I said earlier, inherits from border. So it is a border. There it is. And then we're also using a canvas. So the border has a canvas child. We style the border, so that's the black you see, the sort of the linear gradient on the black margin. The canvas we use to position the glyphs. So a canvas gives you direct control of layout, so that's why we're using a canvas. Let's go to the next breakpoint. This is an implementation of the text view margin interface, and this is how we specify to Visual Studio what our WPF element is that it should lay out in the margin. And we're returning this, again, because we're inheriting from border. So with that, we should, in theory, see a margin running. Visual Studio calls this method 3 times. And there we go. There's our margin.
Excellent.
Thank you.
So Bill, I noticed that you didn't have to do anything when you hit F5 to run that. I saw you pressing F5.
You're right, I didn't. And that's because I created this project from the wizard that comes with the Visual Studio SDK. And extensibility projects do a lot of work under the hood for you. When you create them, you can they modify the build pipeline so that you can, where am I here? I'm lost. Okay, they modify the build pipeline so that they build the deployment unit that Visual Studio uses to load extensions. And those are called V6 files. So I don't know if you've heard of those yet, but they're essentially zip files that contain all of your artifacts and assemblies that you need to deploy an extension. And Visual Studio creates that as part of the build, and it will actually deploy it to that experimental hive for you. So the extensibility project does a lot of work for you. And then when you hit F5, it launches the experimental instance and loads the extension.
Excellent.
So there's one more thing I want to talk about in the demo, though, before we leave this demo, and that is the viewport tracking, which I promised you. So you can see it's got the glyph here that's tracking the viewport, and I want to show you how we did that. So I'm going to add one more breakpoint. If I can make my mouse find this thing. And now when I scroll the viewport here, I'm going to hit that breakpoint. So what's happening here is I'm listening for what's called a layout change on the view. The text view will fire this method or this event anytime the text in the view changes. So that's whether it be scrolling or resizing or underlying changes. So we're listening to that, and then we're calling a method that updates our viewport. And that method works by actually looking at the lines visible in the view and finding the first line and the last line and calculating the height of a glyph in the margin, and then using the coordinates of that top line to find the top. And that's what this code is doing here. We are then calling a scaling method we wrote, this map y coordinate of position, does the scaling. So again, the actual size of the text in the buffer is really large, and our margin is really small. So we're mapping the position of a line number to the margin. And that's, once we have those numbers, all we have to do is set our positions on the canvas, set our left and our top position, and our height.
Excellent.
So that concludes our first demo. We now have a working margin that tracks the view.
Excellent. Is there anything on the colors of the glyphs? Is there the alerts?
Oh, we are going to do that demo next. in fact.
Excellent. Okay.
So the next demo, I'm going to switch to the slides here.
Okay. So
just
while you're doing that, so if we think about it, think about what this code has to do. It needs to find where the methods are, physically located. The methods that have been instrumented with runtime intelligence, and it needs to create glyphs and position them correctly within the margin, so you can see relatively where they are compared to the code. We have a data manager that tells us the methods to look for. We have a code scanner that looks for the method definitions in the buffer and tells us where they are, and it notifies us when they move. And then the margin uses these components to draw the glyphs.
So again, here we are. These are the glyphs, those yellow things, and let's move on. So I'm going to go over real quick some of the supporting code we have to put in here to make this work. The data manager is essentially uses an XML data source. I'm not going to go into detail because reading XML isn't part of this talk, but what we're going to do is read in the XML. The XML has the runtime intelligence data, and it has the information as to which methods that data is tied to, and also contains values as to whether this data has caused an alert or not. And the data manager's job is to create a metric class for each method that has data, and that metric ties together the actual data, the method, and where in the text view, the text buffer, that method is located. And it does that through this snapshot span here. You can see that off to the left. That is a Visual Studio API, and it represents an immutable part of the buffer. So you can actually take snapshots of the text buffer and use them without fear that they will change underneath you as the user is editing code or whatever. So these snapshot spans we use to track the start of the method and the actual body of the entire method.
Excellent.
And the next part is the background parsing. So you imagine we have to watch the buffer as the user is editing it because, we have to watch the buffer as the user is editing it because things can change underneath us. So the scanner's job is to parse that buffer and identify where the methods are in there that we are interested in. So all those runtime intelligence enabled methods, we're going to identify where they are, and then we're going to fire an event when one of them changes, and that event is called the metrics changed event.
Okay, so if I understand this, the margin has a scanner that listens for a metric change event.
That's right. The margin listens for a metrics changed event, and when it sees that, it uses that to then redraw all the glyphs on the margin.
Excellent. Very cool. Okay.
So let me switch back over, and we will begin our next demo. So I'm going to get rid of this. Wrong one. There, I'm going to reload another solution that has the second demo in it. There we go.
Excellent.
Okay, so here's our document map code. You see we've added the data management pieces I just described. And what I'm going to do now is run it like before and talk through the highlights. Again, I'm going to load the same file.
So hopefully you guys are getting a sense of how easy this is to do. It doesn't, it looks relatively straightforward.
All right, so our first stop here is the constructor for our margin again. So I've added some code down here to grab our data manager and also to get a scanner for the buffer. And then we're going to listen for that metrics changed event I told you about, and also for viewport height changed on the text view. So we're going to redraw our glyphs when the viewport's height changes and also when our metrics change. So next, we're in the code scanner now. When I added that listener to metrics changed, the code scanner then has to listen in turn to the underlying buffer. So the code scanner has a reference to the underlying text buffer, and it's listening for its changed event. And when the change handler on that will do the actual parsing. So the next stop should be one of those. Okay, so here I'm deep within the parser, and if there are real parser people in the audience here, this is not a real parser. So what we're doing is we're looking for method signatures in the editor, in the buffer, and then finding the beginning and the end of that method. And then what I wanted to highlight here, though, is that, again, we're using the snapshots to store those positions in our metrics class. So we're creating a snapshot span based on the beginning of the method here. And in the next breakpoint, we're finding the end of the method, and then we're creating a snapshot span that actually encapsulates the entire method. And we're going to use that later to do the lightboxing. And since I know you don't want to see a breakpoint for every method in the buffer, I'm going to disable those and keep going.
Good job.
So now we're in our onMetrics changed handler inside the margin. And what that's doing is it's now going to update the glyphs, and it's doing that. It's going to marshal over to the right thread to do that. And here's the call. And now we're creating glyphs. So I skipped over the update glyphs method. All that does is loop through the metrics and create a glyph for each one. Again, the glyph itself is a WPF control that we built. It's called a two-state glyph because later we're going to use it to change state when the inline charts are hidden versus not hidden. And all we're going to do now is position the glyph on the canvas the way we did the viewport margin. We're setting its dimensions and some style information, and also its color based on whether it's flagged or not. So the metric has a flag, it's red, and if it doesn't, it's yellow. And I'm also adding a mouse handler to navigate, which should hit next after I disable this. All right, so there we are. So there's our glyphs. They're all positioned on the margin. I hover over one. I have a tooltip. You'll remember in the main demo there were flyouts. I omitted those for brevity, but those are actually WPF pop-ups. But this tooltip tells you the same information in less pretty. It just tells you the name of the feature that we're tracking in Runtime Intelligence and the method signature. So if I click on it, I will hit my mouse handler here. And what that does is it takes that snapshot I took of the method start and maps it over to the current text view to create a new snapshot. And then it calls an API called display text line containing buffer position. And what that does is it scrolls that snapshot into position on the viewport. So what we're doing is scrolling that on the viewport, and we're putting it in the middle. That's what this viewport height divided by 2 is here, relative to the top. So we're going to scroll that method into view in the middle of the viewport. I've forgotten what I clicked on, but I think it was this one. So there it is.
Very cool. So what happens if we edit the source file to change a method signature?
That's a good question. I think what will happen, what should happen if we wrote our parser right, is that if we change, say, a method signature like this, it ought to disappear because it's losing track of the method. So yes, here's our onChanged event in the scanner. It's going to kick off a new scan,
Okay.
which is going to kick off a new update. So metrics must have changed,
Okay.
and it's gone.
It's gone. Excellent.
No.
So it's working.
Kinda. Let's put it back. I'd rather have it back. So there it is. There it is back. So that's our scanner is constantly watching the buffer, and it's running every time there's a change.
Excellent. Okay. So we want to talk about
Back to the slides.
Back to the slides, yes. All right. The inline endorments.
So yeah, the inline adornments I kind of went over those before. The adornments are WPF controls that live on the editor's design surface. We have two kinds of adornments. One we're going to make space for in the buffer, and the other we're going to lay over top of the buffer. That's the light box.
So what's the purpose of the light box? I understand putting in the WPF graph, but why the light box?
What the light box does, it's really a usability thing. We had feedback when we were building this that it wasn't immediately obvious what those charts were associated with. So what we did is we decided to light box the method that they're tied to emphasize that those charts relate to that actual method's usage.
Got it. Okay.
And that kind of highlights a rule that we're trying to apply and we think is useful, and that developers don't like distractions when they're coding. And we kind of want to do subtle things to put that data in front of them when they need it, but not have it be in their face distractingly obvious.
That's always good advice.
So,
Okay. So let's go over to here. So we can take a look here and we see that we've got the inline WPF control and we have the light boxing. So these were both created with the WPF data visualization toolkit. We also created the chart viewer so that it could support multiple charts, and you'll see them at the bottom there, so you can rotate through different charts. And then we're not going to go into code explicitly other than to say that the margin adornments are WPF UI elements, and there's two here, the chart control and the light box. And we'll dig a little deeper now.
okay, so we're back to our standard class diagram lead up into demo number 3. This one has 3 different MEF exports. The first I want to call out is we are actually creating our own adornment layer definition. An adornment layer is a way of grouping adornments so that they all have the same Z ordering. So they work in layers, just as you'd imagine. You could specify whether they go under the text or over the text in relation to other adornment layers. So we're creating our own adornment layer, and we're exporting that via MEF to Visual Studio. The other thing we're doing is we are going to listen for text view creation. That's what this IWPF, it's on the far left there if you can't read it. It's the IWPF text view creation listener interface. And what that does is gives us a callback. So Visual Studio is going to call that whenever a text view is created. And we're going to use that as an opportunity to create our adornment manager that does all the work. So the adornment manager, ooh, not too close.
Yeah. Ooh.
The adornment manager actually is event-driven, so it's going to listen to some of the events you've already seen, like the metrics changed event and the layout change event on the text view, and redraw the adornments as needed.
Excellent. So how do you reserve space in the view for the chart? If you guys remember when we brought up the method, we were able to insert a chart and actually physically create some space for it. How's that done?
That is done through our last math export, which is that line transform source provider. It's down there as an inner class on the left there. And what that is a way of telling Visual Studio how to lay out a line in the text buffer. So we specify a provider, which we export, and Visual Studio knows to call that when it's laying out text lines. And our line transform is going to look to see whether a particular line has an adornment on it and make it bigger if need be. So we can lay out the adornment in that space.
Very cool. Okay.
So shall we
Let's
move on
switch back
to the
over.
demo? It's demo time.
Dun, 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 dun.
So again, let me reset things here. Find my mouse. All right, so I'm going to stop the old demo here. I don't want to save that. So here's the third demo. You see we've added the adornment classes here. They are ready to go. So let's do a build and a run. We're going to load our old friend. Main window. Okay, and our first breakpoint, our first stop here is in the line transform source provider I mentioned. Here is where we new up our line transform source that Visual Studio is going to use to lay out the lines in the text view. Again, you can see the MEF attributes here uses some of the same values we used in the margin. So we're going to work only for code content type and a document text view role. Next, this is our callback that a text view was created. So Visual Studio is calling this for us. We're getting our data manager, and we're then going to new up our adornment manager class. Remember, that's the thing that is going to start listening to events and do all the work for us. And here we are in there in that constructor. So again, we're getting a hold of our adornment layer that we created by name. And then we're going to listen to layout changed and our metrics changed here. So here we go, we've got our margin. Let's see what happens when I click on one of them and navigate. Okay, so here I have some new stuff in the create glyph method that toggles the visibility. So now it really is a two-state glyph. What I'm doing is changing the visibility on the metric when the mouse is clicked. And what that does is the metrics visibility handler will sort of invalidate the view for that and cause a layout change.
Excellent.
Let me see. I think I want to set another breakpoint here.
Another breakpoint?
I think so.
All right.
Let's set this one. Let's see what happens. Okay. I'm also going to disable these because, again, there's
So they're just going to be called.
several glyphs on here, and we don't want to see them all. Okay, so here's the visibility changed on the metric. So like I said, it's going to call the listeners for that, which is going to in turn cause a re-layout of the text view. And that re-layout in turn calls this method create visuals. And what create visuals is doing is actually putting in the inline adornments, figuring out where to put them. And it does that. First it looks at the snapshot here. And what it's doing here is it's some code that looks for white space. So we want to align those charts with the indentation level of the method definition. So we're going to add a little fudge factor here as we build our geometry. That's what this I is, the size of the number of characters we're going to indent.
Okay.
So this geometry here we're generating by calling this handy little method called getMarkerGeometry on the text view line collection. And what that gives you is the bounds of any given snapshot in the buffer. So that geometry allows us to figure out how big that snapshot is. And as you can see, as I mentioned, I've indenting it a little bit so we can align the charts up with the method. And then down here, I'm actually using that geometry object to position the adornment and add it to the adornment layer. So the adornment's added to the layer and it's positioned. Now all we have to do is add space for it.
Excellent. So what about the light box?
Let's see if the inline adornments work first.
Okay.
They work.
Excellent.
So we now have inline adornments.
Right.
The light box is done slightly differently. I'm going to enable one more breakpoint. Now when I scroll, you will see that I'm hitting this draw light box method. And that's called, again, in response to a layout change on the view. And what it does is it first removes the old light box from the adornment layer in preparation for redrawing it. And then it rebuilds it. And the light box is actually done with some WPF 2D graphics APIs. We first build a gray rectangle over the viewport that has some opacity set so it looks semi-transparent. And that covers the entire view. And then we loop through our metrics to find holes in that rectangle. So that's what I'm doing down here. I'm getting the snapshot of the entire method. Remember, in the scanner, we identified the entire method bounds and stored a snapshot of that. So we have that. We're building a geometry around that snapshot and then adding it to the rectangle, which has the effect of making those holes transparent. It gives you that white background, which is actually the background color of the editor itself. So once we've built up that geometry group object here, we set it up and plug it right into the canvas here, so position it. So the editor background is actually implemented as a canvas as well. You can just put stuff on it and add it to the adornment layer, and it'll show up.
Excellent.
And that will happen quite a few times, so I'm going to disable that and move on. So there it is. We have a almost completely functional version of, there we go. So that's why I keep this breakpoint disabled. This create visuals method, it's interesting. It gets called all the time, even if the adornments aren't hidden.
So if the graph isn't showing, it still gets called?
It still gets called because we've registered our transform, and it gets called, and when it's called, it won't reserve space for the adornment if it's hidden, but
Okay.
it will get called.
Excellent. Okay, good. That's good to know.
So yeah.
So there's a lot of code. Was it difficult to write these extensions?
There is a lot of code. but a lot of it, as you probably saw, isn't directly related to the extensibility part. Overall, the extensibility API is pretty rich, and there's a bit of a learning curve, so there's some work there. But in terms of enabling us to do what we wanted to do, it was there, and if any of you have worked with the editor in older versions of Visual Studio, it's a lot easier.
Why don't we do a show of hands here? Has anybody worked with the editor Visual Studio 2008? Has anybody tried to do anything in the older version? Okay, so a few of you.
Yeah.
Yeah, this is way better.
It's a lot easier, and especially with the new deployment model as well. It makes the development experience a lot better.
Well, and it allows you to do things you weren't able to do before. I mean, a lot
Right.
of the visualizations that we're doing with Runtime Intelligence,
Yeah.
we wouldn't have been able to do.
It would have been very challenging, if not impossible, to build those kinds of UI elements and integrate them right into the editor's surface like that.
Yeah. So switch back.
Yeah.
Okay. So we did that. Okay. So a couple things. I'm gonna recap here, and then I'm gonna give you guys. We'll talk about maybe some tips that we've learned along the way of building this. But the first thing is, I think it's really important to understand what you're building, like what problem you're trying to solve for when you're doing extensions to Visual Studio. So for us, it was really about helping people build better software, and you know, whether they're using, you know, the agile, lean, or waterfall methodologies didn't really matter to us. The idea of doing feedback-driven development, the idea that you can take intelligence from applications, whether they're running in beta, production, or evaluation, and pull them back is very powerful. On the beta side, you know, we've got a customer, K2, that has been using Runtime Intelligence for quite a while, and they're using it because they want to improve their beta process. They want to know what features people are using. They want to know the performance. You know, Microsoft has something internally called Squim. Again, that was mentioned in the keynote, but you know, in Windows Beta 7, Squim was turned on by default. So they were able to get a lot of feedback from people using Windows 7, you know, way before they released it, and they were able to make a better product as a result. We have a lot of people creating customer experience improvement programs. You know, if you think about the top ISVs and the kind of statistics they gather on how their software is being used and what they do, there's absolutely no reason why, you know, this shouldn't be available to everyone. And then same with the evaluation process. As a matter of fact, we use it in our evaluation process, and we aggregate the data with our CRM systems, and that helps our people sell. So if we step back and think about what some key takeaways are from at least our experience in building this, one was that our integration, the things we showed you here, would not have been possible in Visual Studio 2008, and certainly they would, even the things that were possible would not have been anywhere near as easy. So the amount of work to enable extensions is very reasonable. Most of the work that was done in our data management parser, the WPF controls, not the extensibility part. And the second thing here, WPF makes it easy for you to look like a rock star. And with that, I think the important thing to understand is that if you can't sing, get a voice coach. Okay? And what I mean by that is involve a UI designer to help you look like a rock star. So,
Just
you know,
because you can doesn't mean you should in some
Yes.
cases, especially in the editor, because you know you're all developers, and no one wants to see like distracting things while you're editing code.
Exactly. The blinky tags. Does anybody remember the blinky tags from HTML in the old days? Yeah. Okay. What a horrible idea. Okay. It first came out, and everybody put blinky tags on their website, and it was awful. It was a huge distraction, right? Everybody thought they were cool.
You could do that in the editor if you want.
You can. You know, we could have made our things blink and, you know, done all kinds of animated stuff that would have absolutely served no purpose. And we did involve a UI designer, by the way. You are not seeing the first or second or even third iteration of this. You know, this has been a steady improvement for us to try to put things up there that we thought were functional and yet very appealing visually.
And let me add that having it all be WPF based makes it really easy to involve a UI designer, because once you've got everything factored out into XAML, changing the styles isn't a major undertaking. So.
So I've got a couple predictions for the next time we meet at PDC here, which I don't know when that is yet, but many of you will be using Runtime Intelligence, hopefully to make better decisions faster. As I may have mentioned, it ships right inside Visual Studio, a light version of it, so it's right off the Tools menu. And the second is that there'll be lots of cool Visual Studio editor extensions that will be available, hopefully built by many of you here. One of the things I want to mention is that we will have the source code that we've shown you here today. We'll share that with you. Obviously, we're building a product on this, so we're not going to share all of it that goes back and does all our proprietary, really cool things. But the Visual Studio part.
The other cool stuff will be available.
Yeah, exactly. If you want that stuff, we sell it. It's available. The actual integrations with Visual Studio we're planning to release the same time Visual Studio does. But if you want to sign up for a beta copy of it and play with it, start using it yourself, come see one of us. We have a booth. I'm not sure what our booth number is here. Do we have it listed? Booth 216 and 217 right down there on the floor. Please come talk to us. Come ask us any questions. Bill and I will be down there. Be happy to answer any questions you have about Visual Studio extensibility or Runtime Intelligence itself. There's a number of resources here out at Microsoft. We also have the Runtime Intelligence portal and our blogs where we do post about this kind of stuff. There's some related talks you might want to go to, and they're listed here. I'm sure you guys all have the schedule. And your feedback is important to us. And the thing I want to say here before you guys all leave is my mom had a saying, if you don't have something nice to say about somebody, don't say anything at all. No, I'm just kidding. In that case, you don't need to fill out the feedback. But if you did like our session, we'd really appreciate it if you'd give us positive comments. Does anybody have any questions?
We have 3 minutes for questions. So again, we're at the booth. I think there's mics here too. I don't know if. The scrolling marquee, yes, and the rainbow dividers. We forgot those. You saw my website in 1995, didn't you? Yes?
It seems so common to look for the beginning of a method, end of a method. There are no higher level helper libraries to deal with that?
I asked the same question.
So repeat the question.
Yeah, the question was, it seems like a common thing to parse the buffer and look for the beginnings and ends of methods. And yeah, I asked the same question while we were working on this, and they do not have anything yet. But I do know that yesterday I'd heard that they are opening up their compilers. It was in a talk yesterday, I think. And at some point, I expect they will make that available to actually hook into their parsers, like the Microsoft C# and VB compilers, and actually hook events off of those. I think that would be a good step for them to take. And I've given them that feedback, but right now we have to do it ourselves.
Okay. Other questions?
Does the extensibility, can you use it on the other views, Visual Studio views like the debug view and so forth? Could you
just repeat the question.
The question is, can you look at other views inside Visual Studio and do the same sorts of extensibility? And I'm not sure of that. I suspect not, because I haven't heard talk of that, but I don't know if anybody from the team is in here to address that, but I don't know for sure, so I'm not going to commit to an answer. Anyone else? You have 1 minute.
All right. No, well, thank you very much for coming.
Well, thanks for coming.
Yeah.